Hi everyone, my name is Sara Papi, and I will present you the paper StreamAtt, that is streaming speech-to-text translation with attention-based audio history selection. I will present you the task, the simultaneous speech translation. In the real-world simultaneous translation, a continuous and unbounded speech input is concurrently translated into text in another language. However, in current words in simultaneous translation, this is not true. Instead, they assume to process bounded and often human segmented speech. But this is extremely unrealistic. For this reason, we propose StreamAtt, the first simultaneous speech translation model that is able to process unbounded speech input or audio streams. And I will introduce you the system step by step. I will start from the hypothesis selection, in which, given the speech and then translation hypothesis, we have to determine which part of the output has to be emitted. In this case, this is done by exploiting the cross-attention scores already computed by the model. In this example here, we have the cross-attention between a speech input and the hypothesis, this is an output. And if we assume that the last received speech frames, let's say half speech frames, are unstable, so they are unreliable for generating the output, and we consider that the last word here mostly attends to it, we will emit only the first three words. This is an while discarding output. Then we move to the textual history selection. And this is needed because, of course, during the simultaneous process, we will have a growing context. And since we cannot maintain into memory all the textual history here, we have to select it. And we explore two ways of selecting the textual history information. The first one is the fixed word, in which we select the textual history based on a predefined number of words, let's say 10, 20, or 30 words. The second one is the punctuation, in which we select the last part of the textual history based on strong punctuation marks, such as full stops or exclamation marks, and so on. Having selected the textual history, we move to the audio history selection, in which we exploit again the cross-attention scores. But here they are used to discard which part of the audio is not used anymore for generating the output. This is because since we have selected the textual history, we have a discarded part, and we are not interested anymore in maintaining the audio related to that part, that is the discarded part in red in this image. And since the first speech frames mostly attend to that part, we can safely delete them. And also avoiding growing context also in the audio part. Then we move to the results. And results in the simultaneous translation are evaluated by means of two separate metrics. The first one is the BLE, that evaluates the speech translation quality in common with speech translation tasks. And the second one is the latency. And in this case, we introduce a new metric for latency called StreamLAAL that can handle unbounded speech inputs. And here we present results for two latency regimes that are low latency and high latency, but more results are available in the paper. And we compare the StreamAtt with a baseline and by employing the two textual history selection, the fixed words and the punctuation. And we can clearly see that the StreamAtt model works better than the baseline, and also that the StreamAtt employing the fixed words is better on average. Then we move to the comparison with speech state-of-the-art model that instead work with bounded speech. And this is the case of AlignAtt, a simultaneous translation model. And that here is in blue, And we have the StreamAtt with both fixed words and punctuation in respectively red and green. And we can observe that at low latency, the StreamAtt achieves better results and in general is comparable, while at higher latency, so moving towards the right of the graph, we see a gap between the model working on bounded speech and ours, so indicating a room for improvement. Also, more results and languages are available in the paper. We can conclude that in our paper, we formalize for the first time the problem of concurrently translating unbounded speech input. And for this reason, we propose StreamAtt, that is the first simultaneous story testing model that is applicable to unbounded speech. And for evaluating it, we introduced StreamLAAL, that is the first metric evaluating the latency of translations produced from audio streams, so from unbounded speech. And we validated the performance and results of the StreamAtt by comparing it to prior works, state-of-the-art works across all 8 languages of the MASTI datasets, and we proved that it is comparable or even outperforms at low latency the performance of the prior works. We thank you for the attention, and the code, but also the models employed in the paper are all available on GitHub. Thanks a lot.